Welcome back to the EFI Hardware Podcast, everybody. If you're joining us for the first time, well, you'll notice something a little different about our voices today. You see, we're actually AI voices now, so buckle up because we're going to be diving deep into some seriously technical stuff. But don't worry, every bit of information you're going to hear has been human approved. So today we're going to be talking all about Lambda sensors and how they play a vital role in engine tuning. Now, we know you guys are already pretty familiar with engine performance.
Oh, yeah. Medium to high level, we're assuming here.
Exactly. So we're going to skip right past the basics and jump right into the nitty-gritty.
Yeah, let's get straight to the good stuff.
So our goal today is to give you a rock-solid understanding of how these sensors work, how they interact with different types of fuel.
Because, fuel's not just fuel these days.
It's not just pump gas anymore, right? And we'll also be breaking down the essential differences between tuning with Lambda versus AFR, which is air-fuel ratio.
Yeah, that's a good one that trips people up.
Definitely. And as part of EFI Hardware, Australia's leading aftermarket fuel injection supplier, we're pretty much swimming in this stuff day in and day out.
We see it all the time.
We have a huge range of EFI parts. Everything from Bosch Motorsport oxygen sensors, which are top of the line,
Those are the good ones.
to all the fuel system components you could ever need for an E85 conversion injectors, regulators, filters, pumps, hose, you name it.
Even the hose. Yeah, we got you covered.
And of course, flex fuel sensors because, well, that's kind of essential these days.
Absolutely got to have those.
So without further ado, let's jump right in, shall we?
Let's do it.
All right, so first things first, what exactly is a Lambda sensor?
Okay, so a Lambda sensor, sometimes you'll hear it called an O2 sensor or a Lambda probe. It's basically this little device that sits in your exhaust stream.
It's like the eyes and ears of your engine.
Yeah, exactly. It's like the snitch telling the ECU what's going on in there. And its main job is to measure how much oxygen is present in the exhaust gases.
Which is super important because...
Yeah. It's crucial because this little sensor, it's a cornerstone of your whole engine management system.
Yeah, and if it goes haywire...
If it goes bad, oh boy, you're in for a whole bunch of trouble.
Like, what kind of trouble are we talking about here?
Well, for starters, your fuel consumption could go through the roof.
Nobody wants that.
Nope. And your vehicle's responsiveness, it's going to feel sluggish. You'll lose that pep in its step.
Yeah, that's no fun.
And you might even notice a drop in engine power. And then there's the dreaded inconsistent idle, like your engines just can't make up its mind whether it wants to run or not.
Yeah, that's shaky.
Yeah, exactly. So you definitely don't want a bad Lambda sensor.
No, you don't.
Yeah.
So where do you usually find these sensors hiding out?
Well, typically you'll find them screwed right into the engine's exhaust manifold.
Okay. Makes sense. Got to be close to the action.
Right in the thick of things. But what's really cool is how they work. They actually act like miniature galvanic current sources. It's like a tiny battery that generates a voltage based on this chemical reaction happening across the sensor's material.
I'm picturing like a little power plant in there.
It's kind of like that. And this voltage, it changes depending on the sensor's operating temperature and how much oxygen is swirling around in those exhaust gases.
So when we talk about Lambda sensors, are they all the same or do they come in different flavors?
It's like ordering ice cream. You got your vanilla, you got your chocolate, you got your strawberry. Well, Lambda sensors, they have their own variety pack too.
So what are the different types we need to be aware of?
Well, we can categorize them in a couple of ways. Firstly, by their sensing element, the heart of the operation. So you got your zirconium sensors, which use zirconium oxide. Then there's titanium sensors. Those use titanium oxide. And then you got the big daddy, the wideband sensors.
The heavy hitters.
Exactly. And we can also classify them by their design and wiring configuration, like single wire, 2-wire, 3-wire, 4-wire setups.
Okay, that sounds like it could get pretty complicated.
It's not too bad, but it's interesting to see how they've evolved over time.
Like, how have they changed?
Well, those early single and 2-wire sensors, they relied purely on the heat of the exhaust gases to get up to operating temperature.
So they had to be positioned right next to the engine.
Right, up close and personal, and that could sometimes be a bit limiting.
Yeah, I can imagine.
But then came the 3-wire and 4-wire sensors, and these were a game changer.
What was so special about them?
They had this brilliant idea to include integrated heaters.
Like a little internal furnace.
Yeah, exactly.
Yeah.
So they could reach operating temperature way faster, meaning quicker and more efficient feedback to the ECU.
So they can be placed further away from the engine.
Right, more flexibility in placement closer to the catalytic converter, for example. And just a quick shout out here at EFI Hardware. We stock mostly those advanced multi-wire types from Bosch Motorsport. Precision and speed are everything when you're tuning.
Absolutely. Got to have the right tools for the job. So let's dive a little deeper into the mechanics of these sensors. How does a zirconium sensor, for example, actually communicate with the ECU what's happening in the exhaust?
Okay, so zirconium sensors, they generate a voltage, a signal that tells the ECU what's up. And this voltage, it typically ranges from about 0.1 volts to 0.9 volts.
Okay, so a range of voltage.
Yeah, and a higher voltage, closer to 0.9 volts, means the mixture is rich, meaning there's not much oxygen hanging around in the exhaust.
Okay, so rich mixture, high voltage.
You got it. And conversely, a low voltage, like down near 0.1 volts, that signals a lean mixture, meaning there's plenty of oxygen left over.
Lean mixture, low voltage. Okay, I'm following you.
Good stuff. But here's the catch. These zirconium sensors, they need to be above a certain temperature to work properly, usually around 350 degrees Celsius.
They like it hot.
They need that heat to function accurately.
All right. And what about the titanium sensors? How do those guys work?
Well, titanium sensors, they're a bit different. They don't generate a voltage. They change their electrical resistance based on how much oxygen is present.
So it's like a different language they're speaking.
Yeah, a different way of communicating, but the message is the same.
Okay, so how does that work?
When the exhaust mixture is lean, their resistance is high, like they're putting up a wall.
Like a closed door.
Yeah, and when it's rich, their resistance drops down low. It's like opening the floodgates.
Interesting. So they're more like a gatekeeper than a messenger?
In a way, yeah. And what's cool about titanium sensors is that they react super fast to changes in oxygen compared to zirconium ones.
So they're like the quick draw of the sensor world.
Yeah, they're on the ball. And another key difference, they don't need a separate reference air sample like some zirconium sensors do.
So they're more self-sufficient.
Independent operators.
All right. And then we have the wideband sensors. These sound like they're the real deal.
Oh yeah, these are the rock stars of the sensor world.
So what makes them so special?
Well, unlike the others, which just give you a general idea of rich or lean wideband sensors, they give you a precise, continuous output signal that tells you the exact air-fuel ratio, or more accurately, the lambda value.
So they're not messing around?
Nope, they're all about accuracy, and they achieve this by using an integrated oxygen pump.
Like a miniature air traffic controller.
It's kind of like that this pump keeps a super accurate reference inside the sensor, and the current flowing through it tells you exactly how much oxygen is in the exhaust.
So it's like a constant feedback loop.
Yeah, always monitoring and adjusting.
That's pretty impressive. And you mentioned Lambda, so let's make sure everyone's on the same page here. What exactly is Lambda, and how does it relate to AFR?
Okay, so the stoichiometric air-fuel ratio, it's the perfect ratio of air to fuel for complete combustion, like the holy grail of engine efficiency.
The sweet spot.
Yeah. For gasoline, it's usually around 14.7 parts of air to 1 part of fuel by mass.
Okay, so 14.7 to 1.
That's the magic number. And lambda, denoted by the Greek letter lambda. It's basically a way to express the actual air-fuel ratio relative to this stoichiometric ratio.
So it's a comparison tool.
Exactly. If lambda is 1.0, it means your engine is running at that perfect 14.7 to 1 ratio for petrol.
Got it. So 1.0 is ideal.
For petrol, yeah. And if lambda is less than 1, like 0.9, that means you're running more fuel than air.
Rich mixture lambda less than 1.
You got it. And if lambda is greater than 1, like 1.1, that means you're running lean more air than fuel.
Lean mixture lambda greater than 1. Okay.
I think I'm starting to get this.
It's clicking good. And just a little side note, for tuning purposes with petrol engines, the optimal lambda ranges can vary depending on what you're trying to achieve.
So different goals, different lambda targets.
Exactly. If you're looking for maximum power, you might aim for a slightly rich mixture, somewhere between 0.85 and 0.95 lambda.
Okay, slightly rich for power.
But if you're all about fuel economy, you might lean things out a bit and target lambda between 1.1 and 1.2.
Lean for economy. All right, that makes sense.
And it's important to remember that these are just general guidelines. Every engine is different, so you always want to tune carefully and monitor your results.
Absolutely. Safety first. And this whole lambda thing, it gets even more important when we start talking about different types of fuel, right? Oh yeah, that's where lambda really shines.
Because not all fuels have the same ideal AFR.
Exactly. You can't just use the same AFR target for petrol and then switch to E85 and expect everything to run smoothly.
So what's the problem there?
Well, different fuels have different stoichiometric AFRs, for example. E85, it's a blend of ethanol and gasoline. It has a much lower stoichiometric AFR, around 9.8 to 1.
Okay, so much lower than petrol.
Yeah, and if you were to stick with a fixed AFR target, let's say 12.5 to 1, you could end up with a really messed up mixture depending on what fuel you're using.
So it could be rich on one fuel and lean on another.
Exactly, and that's a recipe for disaster.
Yeah, that's not good for your engine at all.
No, not good at all.
So how does Lambda help us avoid this confusion?
Well, the beauty of Lambda is that it remains consistent across different fuels.
So it's like a universal language.
Exactly. For example, if you're tuning a turbocharged engine under boost and you're aiming for a lambda of 0.80 to be safe from detonation, that 0.80 target will generally hold true whether you're running petrol or E85.
So Lambda takes the guesswork out of it.
Exactly. It gives you a clear target no matter what's in your tank.
That's fantastic. Can you give us a practical example to really illustrate this?
Sure. Let's say we're sticking with that lambda target of 0.80 on petrol with a stoichiometric AFR of 14.7 to 1. That translates to an actual AFR of about 11.8 to 1.
Okay, so 0.80 Lambda equals 11.8 AFR on petrol.
Exactly. Now, if you switch to E85 with its stoichiometric AFR of 9.8 to 1, that same lambda target of 0.80 gives you an AFR of about 7.8 to 1.
So the Lambda stays the same, but the AFR changes based on the fuel.
You got it. Lambda is the constant. The AFR is the variable. And this is why it's so important to understand and tune with Lambda, especially if you're thinking about converting to E85.
And we've got you covered at EFI Hardware for all your E85 conversion needs.
Oh, yeah. We've got everything you need. Injectors, pumps, filters, sensors, you name it.
So you can make the switch with confidence. All right. So just to recap, AFR is the raw ratio of air to fuel molecules, while Lambda is that ratio expressed relative to the ideal ratio for that specific fuel.
That's a great way to put it.
So Lambda is all about relativity.
It's all about context.
That brings us to the big debate. Lambda versus AFR tuning.
The age-old question.
Some people swear by AFR, others are diehard Lambda fans.
It's all about personal preference, really.
But are there any objective advantages to using one over the other?
Well, I'd say Lambda has a few tricks up its sleeve.
Like what?
For starters, it's super easy to understand how rich or lean your mixture is when you're looking at Lambda.
Because it's a percentage.
Exactly. If you see a Lambda of 0.85, you know right away that your engine's running 15% richer than the stoichiometric.
No matter what fuel you're using.
That's the key, and this makes it way easier to make adjustments to your fuel tables without having to constantly calculate AFRs for different fuels.
So it simplifies the whole tuning process.
It streamlines everything.
That's a huge advantage. And another bonus is that Lambda helps avoid that common mistake of quoting AFR targets for ethanol using petrol's stoichiometric value.
Yeah, that can get really messy.
It can lead to all sorts of problems.
Big time.
So Lambda keeps things clear and consistent.
It's the universal language of tuning.
I like it. So Lambda seems to have the edge, especially when you're dealing with multiple fuels.
It's definitely the way to go in those situations.
Now, what if someone suspects that their Lambda sensor is acting up? Are there any checks they can do to make sure it's working properly?
Yeah, there are a few things you can do if your sensor has a heater circuit, which most modern ones do. You can check if it's getting power. You should see around 12 volts with the ignition on.
Okay, so check the power supply.
And you can also try monitoring the sensor's output signal using a multimeter. But if you really want to get a detailed picture, an oscilloscope is the way to go.
That's the professional tool.
Yeah, it lets you see the waveform and make sure it's fluctuating properly for a zirconium sensor before the CAT. You should see an oscillating waveform between 0.1 and 0.9 volts with a frequency of 1 to 5 hertz at idle.
Okay, so a nice steady wave.
Yeah, and titanium sensors before the CAT, they'll have faster fluctuations between 0.2 and 4.5 volts.
So a bit more jumpy.
Yeah, they're quicker on the draw, and widebands, they signal through current flow, so the voltage readings can vary depending on the sensor.
So it's a bit more complicated.
But the principle is the same. You want to see a clear signal that corresponds to the engine's operating conditions.
And if you're not sure, always refer to the manufacturer's specifications.
Absolutely. And don't forget, EFI Hardware has a huge range of high-quality motorsport sensors, including oxygen sensors, so we can help you find the right one for your application.
Yeah, we've got you covered. And speaking of sensors, what are some of the common reasons they might fail or give you inaccurate readings?
Well, contamination is a big one. Leaded fuel, silicones, oil, anything that gets into the exhaust stream can gunk up the sensor.
So keep it clean.
And like any component exposed to those harsh conditions, sensors wear out over time. The catalyst material inside can degrade and they become sluggish.
So they get old and tired.
Yeah. And electrical damage can also be a problem. Physical impact, bad wiring, voltage spikes, they can all fry the sensor.
So handle with care.
Absolutely. So to sum it all up, what are the key takeaways about Lambda sensors and tuning?
The big picture.
Well, first and foremost, Lambda sensors are absolutely crucial for modern engine control. The feedback loop that keeps everything running smoothly.
The unsung heroes.
And understanding the difference between Lambda and AFR is essential for accurate tuning, especially when you're working with different fuels.
Lambda is the key.
And using Lambda as your primary tuning reference has a lot of advantages. It's clear, consistent, and easy to understand.
It simplifies everything.
Exactly. It takes the guesswork out of tuning.
And for all your EFI needs, including Lambda sensors and E85 conversion parts,
We've got you covered at EFI Hardware.
we're your one-stop shop.
Head on over to our website or give us a call. We're always happy to help. Well, that's all the time we have for today. Thanks for joining us on the EFI Hardware Podcast.
And keep those engines running smooth.
We'll catch you next time.
See ya.